The amount of computation necessary for one shot versus reasoning agentic AI models could be 100 times, 1,000 times, and even potentially even more as the amount of research and basically reading and comprehension that it goes off to do. And so the amount of computation that has resulted in agentic AI has grown tremendously. And of course, the effectiveness has also grown tremendously. The amount of hallucination has dropped significantly. It can now use tools and perform tasks. Enterprises have been opened up. As a result of agentic AI and vision language models, we now are seeing a breakthrough in physical AI, in robotics, autonomous systems. So the last year, AI has made tremendous progress, and agentic systems, reasoning systems, is completely revolutionary. Now, we built the Blackwell NVLink 72 system, a rack scale computing system for this moment. We've been working on it for several years. This last year, we transitioned from NVLink 8, which is a node scale computing. Each node is a computer, to now NVLink 72, where each rack is a computer. That disaggregation of NVLink 72 into a rack scale system was extremely hard to do, but the results are extraordinary. We're seeing orders of magnitude speed up, and therefore energy efficiency, and therefore cost effectiveness of token generation because of NVLink 72. Over the next 5 years, we're going to scale into, with Blackwell, with Reuben, and follow-ons, to scale into effectively a $3 to $4 trillion AI infrastructure opportunity. The last couple of years, you have seen that CapEx has grown in just the top 4 CSPs has doubled and grown to about $600 billion. So we're in the beginning of this build out, and the AI technology advances has really enabled AI to be able to adopt and solve problems to many different industries. NVIDIA builds very different things than ASICs. But let's talk about ASICs first. A lot of projects are started. Many startup companies are created. Very few products go into production. And the reason for that is it's really hard. Accelerated computing, unlike general purpose computing, you don't write software and just compile it into a processor. Accelerated computing is a full stack co-design problem. And AI factories in the last several years has become so much more complex because of the scale of the problems have grown so significantly. It's really the ultimate, the most extreme computer science problem the world's ever seen, obviously. The models are changing incredibly fast, from generative based on autoregressive to generative based on diffusion to mixed models to multimodality. The number of different models that are coming out that are either derivatives of transformers or evolutions of transformers is just daunting. One of the advantages that we have is that NVIDIA is available in every cloud. We're available from every computer company. We're available from the cloud to on-prem to edge to robotics on the same programming model. And so it's sensible that every framework in the world supports NVIDIA. When you're building a new model architecture, releasing it on NVIDIA is most sensible. And so the diversity of our platform, both in the ability to evolve into any architecture, the fact that we're everywhere, and also we accelerate the entire pipeline. You know, everything from data processing to pre-training to post-training with reinforcement learning, all the way out to inference. And so when you build a data center with NVIDIA platform in it, the utility of it is best. The lifetime usefulness is much, much longer. And then I would just say that in addition to all of that, and it's just a really extremely complex systems problem anymore. You know, people talk about the chip itself. There's one ASIC, the GPU, that many people talk about. But in order to build Blackwell, the platform, and Reuben, the platform, we had to build CPUs that connect fast memory, extremely energy efficient memory for large KB caching necessary for agentic AI, to the GPU, to a super NIC, to a scale up switch we call NVLink, completely revolutionary when we're in our 5th generation now, to a scale out switch, whether it's quantum or Spectrum X Ethernet, to now scale across switches so that we can prepare for these AI super factories with multiple gigawatts of computing all connected together. We call that Spectrum XGS. We just announced that at Hot Chips this week. And so the complications, the complexity of everything that we do is really quite extraordinary. It's just done at a really, really extreme scale now. And then lastly, if I could just say one more thing, we're in every cloud for a good reason. And not only are we the most energy efficient, our perf per watt is the best of any computing platform. And in a world of power limited data centers, perf per watt drives directly to revenues. And, you've heard me say before that in a lot of ways, the more you buy, the more you grow. And because our perf per dollar, the performance per dollar is so incredible, you also have extremely great margins. So the growth opportunity with NVIDIA's architecture and the gross margins opportunity with NVIDIA's architecture is absolutely the best. And so there's a lot of reasons why NVIDIA is chosen by every cloud and every startup and every computer company. We're, really a holistic, full stack solution for AI factories. The CapEx of just the top 4 hyperscalers has doubled in 2 years. As the AI revolution went into full steam, as the AI race is now on, the CapEx spend has doubled to $600 billion per year. There's 5 years between now and the end of the decade, and $600 billion only represents the top 4 hyperscalers. We still have the rest of the enterprise companies building on-prem. You have cloud service providers building around the world. United States represents about 60% of the world's compute. And over time, you would think that artificial intelligence would reflect GDP scale and growth, and would be, of course, accelerating GDP growth. Our contribution to that is a large part of the AI infrastructure. Out of a gigawatt AI factory, which can go anywhere from 50 to, plus or minus 10%, let's say 50 to 60 billion, we represent about 35 plus or minus of that, and 35 out of 50 or so $1 billion for a gigawatt data center. Of course, what you get for that is not a GPU. I think people were famous for building the GPU and inventing the GPU, but as you know, over the last decade, we've really transitioned to become an AI infrastructure company. It takes 6 chips just to build 6 different types of chips just to build a Reuben AI supercomputer. And just to scale that out, you have hundreds of thousands of GPU compute nodes and a whole bunch of racks. And so we're really an AI infrastructure company, and we're hoping to continue to contribute to growing this industry, making AI more useful, and then very importantly, driving the performance per watt, because the world, as you mentioned, limiters, it will always likely be power limitations or AI infrastructure or AI building limitations. And so we need to squeeze as much out of that factory as possible. NVIDIA's performance per unit of energy used drives the revenue growth of that factory. It directly translates. If you have a 100 megawatt factory, per 100 megawatt drives your revenues. It's tokens per 100 megawatts of factory. In our case, also, the performance per dollar spent is so high that your gross margins are also the best. But anyhow, these are the limiters going forward, and $3 to $4 trillion is fairly sensible for the next 5 years. The China market, I've estimated to be about $50 billion of opportunity for us this year. If we were able to address it with competitive products, and if it's $50 billion this year, you would expect it to grow, say, 50% per year, as the rest of the world's AI market is growing as well. It is the second largest computing market in the world, and it is also the home of AI researchers. About 50% of the world's AI researchers are in China. The vast majority of the leading open source models are created in China. And so it's fairly important, I think, for the American technology companies to be able to address that market. But it's used all over the world. The open source models that have come out of China are really excellent. DeepSeek, of course, gained global notoriety. Huang is excellent. Kimi is excellent. There's a whole bunch of new models that are coming out. They're multimodal, they're great language models. It's really fueled the adoption of AI in enterprises around the world because enterprises want to build their own custom proprietary software stacks. And so open source models really important for enterprise. It's really important for SaaS, who also would like to build proprietary systems. It has been really incredible for robotics around the world. And so open source is really important. And it's important that the American companies are able to address it. It's going to be a very large market. We're talking to the administration about the importance of American companies to be able to address the Chinese market. As you know, H20 has been approved for companies that are not on the entities list, and many licenses have been approved. And so I think the opportunity for us to bring Blackwell to the China market is a real possibility. And so we just have to keep advocating the sensibility of and the importance of American tech companies to be able to lead and win the AI race and help make the American tech stack the global standard. We now offer 3 networking technologies. One is for scale up, one is for scale out, and one for scale across. Scale up is so that we could build the largest possible virtual GPU, the virtual compute node. NVLink is revolutionary. NVLink 72 is what made it possible for Blackwell to deliver such an extraordinary generational jump over Hopper's NVLink 8. At a time when we have long thinking models, agentic AI reasoning systems, the NVLink basically amplifies the memory bandwidth, which is really critical for reasoning systems. And so NVLink 72 is fantastic. We then scale out with networking, which we have 2. We have InfiniBand, which is unquestionably the lowest latency, the lowest jitter, the best scale out network. It does require more expertise in managing those networks for supercomputing, for the leading model makers. InfiniBand, Quantum InfiniBand is the unambiguous choice. If you were to benchmark an AI factory, the ones with InfiniBand are the best performance. For those who would like to use Ethernet, because the whole data center is built with Ethernet, we have a new type of Ethernet called Spectrum Ethernet. Spectrum Ethernet is not off the shelf. It has a whole bunch of new technologies designed for low latency and low jitter and congestion control. And it has the ability to come closer, much, much closer to InfiniBand than anything that's out there. And we call that Spectrum X Ethernet. And then finally, we have Spectrum XGS, a gigascale for connecting multiple data centers, multiple AI factories into a super factory, a gigantic system. You're going to see that networking obviously is very important in AI factories. In fact, choosing the right networking, the performance, the throughput improvement, going from 65% to 85% or 90%, that kind of step up because of their networking capability effectively makes networking free. Choosing the right networking, you'll get a return on it like you can't believe, because the AI factory, a gigawatt, as I mentioned before, could be $50 billion. And so the ability to improve the efficiency of that factory by tens of percents results in $10-20 billion worth of effective benefit. And so, the networking is a very important part of it. It's the reason why NVIDIA dedicates so much in networking. It's the reason why we purchased Mellanox 5.5 years ago. And Spectrum X, as we mentioned earlier, is now quite a sizable business. And it's only about 1.5 years old. So Spectrum X is a home run. All three of them are going to be fantastic. NVLink, scale up, Spectrum X and InfiniBand, scale out, and then Spectrum XGS for scale across. Reuben, we're on an annual cycle. And the reason why we're on an annual cycle is because we can do so to accelerate the cost reduction and maximize the revenue generation for our customers. When we increase the perf per watt, the token generation per amount of usage of energy, we are effectively driving the revenues of our customers. The perf per watt of Blackwell will be, for reasoning systems, an order of magnitude higher than Hopper. And so for the same amount of energy, and everybody's data center is energy limited by definition, for any data center that using Blackwell, you'll be able to maximize your revenues compared to anything we've done in the past, compared to anything in the world today. And because the perf per dollar, the performance is so good that the perf per dollar invested in the capital would also allow you to improve your gross margins. To the extent that we have great ideas for every single generation, we could improve the revenue generation, improve the AI capability, improve the margins of our customers by releasing new architecture. So we advise our partners, our customers to pace themselves and to build these data centers on an annual rhythm. Reuben is going to have a whole bunch of new ideas. I paused for a second because, I've got plenty of time between now and a year from now to tell you about all the breakthroughs that Reuben's going to bring. Reuben has a lot of great ideas. I'm anxious to tell you, but I can't right now. And I'll save it for GTC to tell you more about it. Nonetheless, for the next year, we're ramping really hard into Grace Blackwell GB200, and then now Blackwell Ultra GB300. We're ramping really hard into data centers. This year is obviously a record-breaking year. I expect next year to be a record-breaking year. And while we continue to increase the performance of AI capabilities as we race towards artificial superintelligence on the one hand, and continue to increase the revenue generation capabilities of our hyperscalers on the other hand. Well, I think that the best way to look at it is we have reasonable forecasts from our large customers for next year, a very significant forecast. And we still have a lot of businesses that we're still winning and a lot of startups that are still being created. Don't forget that the number of AI native startups was 100 billion funded last year. This year, the year's not even over yet. It's 180 billion funded. If you look at the top AI native startups that are generating revenues, last year was $2 billion. This year is $20 billion. Next year being 10 times higher than this year is not inconceivable. And the open source models is now opening up large enterprises, SaaS companies, industrial companies, robotics companies to now join the AI revolution, another source of growth. And whether it's AI natives or enterprise SaaS or industrial AI or startups, we're just seeing just an enormous amount of interest in AI and demand for AI. Right now, the buzz is everything sold out. H100 is sold out. H200s are sold out. Large CSPs are coming out, renting capacity from other CSPs. And so the AI native startups are really scrambling to get capacity so that they could train their reasoning models. And so the demand is really, really high. But the long-term outlook between where we are today, CapEx has doubled in 2 years. It is now running about $600 billion a year just in the large hyperscalers. For us to grow into that $600 billion a year, representing a significant part of that CapEx, isn't unreasonable. And so I think the next several years, surely through the decade, we see really significant growth opportunities ahead. Let me conclude with this. Blackwell is the next generation AI platform the world's been waiting for. It delivers an exceptional generational leap. NVIDIA's NVLink 72 rack scale computing is revolutionary, arriving just in time as reasoning AI models drive order of magnitude increases in training and inference performance requirement. Blackwell Ultra is ramping at full speed and the demand is extraordinary. Our next platform, Reuben, is already in fab. We have 6 new chips that represents the Reuben platform. They've all taped out to TSMC. Reuben will be our 3rd generation NVLink rack scale AI supercomputer. And so we expect to have a much more mature and fully scaled up supply chain. Blackwell and Reuben AI factory platforms will be scaling into the $3 to $4 trillion global AI factory build out through the end of the decade. Customers are building ever greater scale AI factories, from thousands of Hopper GPUs in tens of megawatt data centers to now hundreds of thousands of Blackwells in 100 megawatt facilities. And soon we'll be building millions of Reuben GPU platforms powering multi-gigawatt, multi-site AI super factories. With each generation, demand only grows. One-shot chatbots have evolved into reasoning agentic AI that research, plan, and use tools, driving orders of magnitude jump in compute for both training and inference. Agentic AI is reaching maturity and has opened the enterprise market to build domain and company-specific AI agents for enterprise workflows, products, and services. The age of physical AI has arrived, unlocking entirely new industries in robotics, industrial automation. Every industrial company will need to build 2 factories, one to build the machines and another to build their robotic AI. This quarter, NVIDIA reached record revenues and an extraordinary milestone in our journey. The opportunity ahead is immense. A new industrial revolution has started. The AI race is on.